Before we start, I want to see how many of the people in the audience are working on or are planning to work on some aspect of the PRISM program. Okay. Over the next year. Right. The third talk in this series is on the software plane, the work that's being done at DECwest, and the speaker is Dave Walp, who some of you might remember as one of the software persons on PPA or Andromeda. He's now working in the DECwest software group, and he's going to talk about their software activities.
Okay. First off, there was a mistake in the announcement. John Gilbert's still there. He's still the software engineering manager. I work for John along with a lot of other people. So don't worry, you don't have to send any messages. A little overview of what I'm going to talk about. I'd like to start out by going over with the product names. There are quite a few different things that we're working on. I'm going to discuss what the strategy is behind the two operating systems that we're working on, the relationship between them, and then I'm going to go into what particularly we are doing for the two products, the database, which is Cheyenne, and the compute server, which is Glacier. And finally, I'm going to talk about the compiler group and what they're doing. By the way, these slides are for the large part not mine. They're a combination of slides that Dave Cutler gave to the STF and Ben Schreiber and Jeff East have been giving. Ben is the project leader for Glacier, the compute server, and Jeff is the project leader for the Cheyenne part, the software. So, project names. PRISM Alteryx, pretty much a follow-on to VAX Alteryx. Mica. It's the proprietary operating system that we're building out at DECwest. Quartz is the relational database software. That's being done in Colorado. Pillar, which you may have heard, and SIL are the languages that we're using to implement Mica. The two server systems that we are working on are Cheyenne and Glacier. Cheyenne is the database server. Glacier is the compute server. Cheyenne is made up of Stone, which Rob talked about, Mica, which is the operating system, and Quartz, which is the software being done in Colorado. Glacier is a combination of Moraine, which Rob talked about, and Mica, which is the operating system we're doing. Now, old terminology here is p.tbd or p.vms. It's Mica. Mica is now the operating system, the name that we are now using. Okay. We're doing two operating systems. We're doing Mica and PRISM Alteryx. PRISM Alteryx is the industry standard. It's a follow-on from, or a port from VAX Alteryx. It's aimed at the workstations. Mica is proprietary, addresses commercial market needs. It also does, has some contemporary computing concepts, and is very extensible. Both these operating systems share a large number of components, the calling standard and a number of first layer products that go on top of it. We're also sharing a number of the operating systems components itself in the long term. PRISM Alteryx is a port of VAX Alteryx. Over the long term, VAX Alteryx group will supply us with a number of things. As it stands now, we take a copy of their master pack with all their sources, and we're going to make it run on the workstations. A number of things will long term live on the VAX Alteryx, and we'll just pull those off when it's time for us to release. We're compatible totally with VAX Alteryx. What runs on there will run on here. What we're planning to do long term with Prism Ultrix is add more and more components of Mica in it. We are calling this a world class because we're cleaning up a number of things that existed in Ultrix, being that are Unix that has gone from port to port to port. Again, it shares a common layered architecture, the calling standard, a number of the layered products with Mica. It's very similar to VMS. A number of these things are very compatible. We're trying to follow standards here. The POSNX is becoming more and more standard, more and more steady. And we're eventually going to port this to 64-bit. For the first release of Ultrix, we're supporting Shrike, which is a workstation that's being developed in Hudson, I believe. As you can see, that's only a year away. So we're quickly getting our act together and doing it. Again, it shares components with Mica, with the first level, the layer products, the AIA, the DECwest stuff. The third bullet there, the Mica kernel and memory management, we're trying to do that, but it's not clear without doing major rework how much of that we're going to be able to do given our constraint, our scheduling constraints. We get ANSI C and Fortran compiler to go out the door the first time, and we're supporting the interconnects. Release 1.1, which is not all that much, it's just a quarter later, we're doing Osprey. Osprey is potentially a multiprocessor system where Strike is a single and higher performance. At this point, we're only going to be doing, I believe, asymmetric multiprocessing. The second release, major release of Ultrix, will be on the Moraine hardware, and that will be used as a compute server. That will have symmetric multiprocessing, and a lot of the concepts that we're putting in Mica will be this time ported into Ultrix or put into Ultrix. At that time, we'll also have vectorizing and decomposing compilers, the C and the Fortran. Also, we're going to be adding, like I said, pieces of the Mica I/O and file system. Long term, we're going to follow the standard. I believe that's POSNX that we're shooting for right now, which is a shared corporate strategy with VAX Ultrix. Again, we feel that we can supply a set of layered products on top of it, which is going to make software engineering very good. The CASE, which is the computer-aided software engineering, and the integrated program support environment tools, which will allow the compilers, the source control, the build procedures all to work together in an integrated environment. We're planning to work with other systems besides Ultrix systems. There's support for, hopefully at this time, for DFS work groups. The corporate RPC will be implemented. Also, like Rob says, we've been working a lot on the availability and reliability, and we're going to be pulling those components out of Mica which implement that and bring them into the Ultrix thing. This is part of, pieces of Mica will become part of Prism Ultrix. Okay. Mica. Mica is the base system. It's a proprietary thing. It's the base system for the two server products that we're working on. It implements VMS-compatible runtime layered stuff such as AIA, DECwest, same languages. Also, yes, layered product programming interface. Yes, we are doing some VMS system service emulation. However, it will only be for those things that we think that applications are using. We have taken, we have a number of people working on applications, understanding what VMS system services they could call, and trying to emulate those. We're not doing the system services that layered products typically use. Okay, we're using VMS also as a front end for these at release 1 of Mica. VMS is where you will do your editing and that type of work. When you want to compile or you want to execute it, it will happen over on the Mica system or running on Moraine or whatever. Again, this is a proprietary operating system like VMS. It addresses commercial marketplace requirements. It's very extensible, and we're putting a number of contemporary computing concepts that have come along in the industry since VMS was written into this. We're being very formal about how we define the interface and how it's called, and internal to the operating systems, backdoors are going away in a big way. This is very nicely structured stuff. This security model. Oh yeah, about the design, we're going through a very extensive writing a working design document up front, which is in the neighborhood of 60 chapters, each of which are running around 40 to 50 pages. So this is a massive document that we're working on. The process for changing the design requires us to go back through an ECO process to change this. So these interfaces are extremely well defined and are not subject to a whole lot of change. As we find problems, we'll go back and we'll ECO the document. We believe that it is very portable to the 64-bit architecture. There's very little macro code in it. Most of it is written in the higher level language pillar, currently CIL. It won't be as simple as a simple recompile. There are components of it which do understand the architecture and understand 64 bits, but we don't think this is going to be a major effort. Currently, I mean, we're starting out as something that works with VMS, and it will be a marketing decision as to when we go to a general purpose system. The user will still see his VMS interface, the interface he's come to know and love. Okay. First release of Mica will be to support the Glacier system. This is a compute server. I'm going to talk about a number of the base system components, the SMP and that later in the talk. Interesting note, we're going to go directly to DECnet Phase 5. We're not going to even try to do Phase 4. We're going to be only doing end-node support. We're hoping to have vectorization and decomposing Fortran and C compilers, and other things. A nice set of tools so that you can get your program up and running that the user is currently familiar with the VAX product set, such as the debugger and the performance and coverage analyzer tools. Release 2, we're supporting Cheyenne. Cheyenne is the database server. We add some additional features into the base system. Most of these are for OLTP-based support. We also add some more performance and nicer interface type things, such as a deck window, system management. On top of Mica at this time, to make up the Cheyenne product, is the Quartz software, and we're talking from 100 to 600 transactions per second. High availability and reliability are extremely important in this marketplace. Two main thrusts of the Mica operating system: OLTP, and that's for the Cheyenne product and trying to get digital into that market space. We're trying to work with existing database applications and vendors. And the other big focus is for additional languages and layered products and generalizing the Mica operating system into a general purpose operating system. Again, it is a marketing decision when we go from a server that you're hidden behind VAX and VMS to you become a full purpose operating system. We also, at some time, are going to migrate to the 64 bits. And we're going to try to be compliant with POSNIC. Now this is Mica is going to be compliant. Now we think we can do at the same schedule and the same type of things that VMS is currently planning on doing. This part of the talk talks about some more technical pieces of Mica. Thing to note, we believe we've isolated somewhere in the neighborhood of 80 patents in the software for Mica. Our first wave to protect Digital's investment and to get something to barter with other companies to get some of their patents, we're looking at like 15 to 20. So there's quite a bit of new and innovative work being done. Mica is being written in a high-level language. There's very, very little macro code. And we're trying to do that as much as we can. We believe it's going to be portable to the 64-bit Prism and future architectures beyond Prism. It's being written in such a way that it's hidden. You're not allowed to do the nasty things that make it very difficult to make portable. Data structures within the operating system have been highly defined and have very formalized interface. We're calling these objects. Now this is not, although it has similarities to the objects that you hear in the literature, it's not the same thing. Examples of objects are processes, threads, events, I/O. It's a data block, and there can be associated data blocks with it. On an object, you can perform operations such as deleting it, which is consistent across all objects. It's given an object ID, you can say, I want this object to be deleted. We also have cheap threads from Robert Hall. Each one of these, multi-threading, real multi-threading is what we're doing here. A process is now the address space, a thread is the schedulable entity. And we're going to have multiple threads per process to support parallel processing. Okay. Symmetric multiprocessing, we're going to come right out the door. VMS is supporting this in version 5. Our first release will have it there. Determine the number of processes at boot time. Programs are not written to know the number of processors, excuse me. They just run. We have a lot of the vector support. We're only saving the vector registers when they're used, not like general registers which are saved every time that a process context occurs. We're really working to optimize that because that looks to be a fairly intense operation to save all the vector registers. The layered I/O, which I'll talk about in the next slide, we've extended the concept that VMS developed of port drivers and, I can't think what the upper level, the two driver, class, port and class drivers. And now we've got multiple levels. We're supporting shadow and striping, and we have something called the configuration management. At boot time, this is the piece of software that goes out there and finds out what devices exist and how they're named and how they're organized. Also, during the running of the system, this is the piece, the higher level piece of the software that understands about fault management. It understands when it sees a number of soft types of errors coming from this particular disk that failures going to be happening and maybe we should move over to another disk. It sees the global picture. It's the top of the hierarchy. This is a diagram of layered I/O. A typical user would access something called My Volume, and from there, the volume is implemented in many different things. What's interesting to note, the components on the left are function processors. These are very much equivalent to VMS drivers. The components, the diagram on the right is function processor units, equivalent to a UCB or an actual thing. Above the first level, they're more like pseudo devices of sorts. The interface between them is extremely well defined. You can very easily pull them out and put them in. The interface between shadowing and striping is identical, so you can take out the striping function processor unit in a particular thing and just have shadowing, or you can pull out the shadowing. They all implement, there's several different groups of function processors, and a group has the same thing. What striping is done for performance, and what it does is it spreads a file across two different disks. And as one head's seeking, the other one's reading, and we go back and forth with that. Shadowing is done largely for reliability, and we have duplicate copies of the same thing. Interesting to note, I think there's like 3 levels of function processors underneath the MSCP function processor yet. Considering the size of memory that we're dealing with in the prison systems, we've done a number of things to really deal with memory management. We've got much larger page sizes, 64, 8K, but 64 for protection. We're doing copy unmodified. We're also doing some very good things for sparse address space support. We're also, you don't have to install images anymore, they're automatically shared. Since everything in the operating system is object-based and you access it if it was an object and through a defined set of routines, in that is where the security lives. By accessing an object, you go through the security check that you can access it. So it is consistent throughout the entire system, and it's done by ACLs. We no longer have privilege mask and things like that. Everything is identifiers. We're supporting remote procedure calls initially because I believe of scheduling constraints. We're supporting VAX RPC. We're hoping to go to the corporate RPC as soon as we can. And we have this concept called protected subsystem. And what that is a separate process running in the Mica that has its, I'd say, somewhat akin to an ACP kind of concept, except the communication to it is done via the remote procedure calls. We see the ability to extend the operating system using protected subsystems. We think we can do a whole lot with them. One of the big things that we're working on is impersonation, such that one of these protected subsystems can say, let me access this file or whatever as if I were the client who called me initially, or let me access it as if I was the client plus my additional privileges. So there's a lot of work being done in that area. Also, we're doing 2 different variations of this, and that is many users going to one subsystem, and then there's also the many users going to many different protected subsystems. Implement the same protected subsystem for performance reasons. The system manager server is implemented as a protected subsystem. We're pulling system management together, much like VMS is trying to do now, into one consistent picture of the overall system. There's no longer 3 dozen different utilities, and to bring a new user online, you got to bop between all these. There will be a single user interface, and you'll go in there and you'll say, I want to add a new user, and it'll all happen. On the Mica side, the server that understands how to perform system management functions is a protected subsystem. Programs that run on Mica, we're stressing AIA. We're probably going to be the first one using it. VMS is doing some stuff now, and I believe some other operating systems are looking at it. This is an architecture that lives above the system service of a particular operating system that is available across all operating systems, several different operating. So if you code your program so you only use AI services, you can take it from VMS, you can take it to Mica, you can take it to whatever other system does it. We've been working with a number of different people with that. DEC Windows is actually something that's defined in AIA. Trying to think what some of the other stuff is. Some of the math RTL and some of the time services and naming services also fall into that. It's a very large set of things. We're pushing forward those things that we believe we need to get out the door. The calling standard has been architected, and we're proceeding on that, and it includes more and is extended farther than the VMS calling standard. In fact, again, both Mica and Alteryx have the same calling standard, have the same object format, have the same condition handling. So that layered products, it doesn't matter whether they're going for Alteryx or for Mica, will run on both systems. And we think that's very, very important. Another component that we're cleaning up is the RMS interface. It's much more parameter orientated. You do 95% as just parameters in your open calls, but there are all the flexibility that we have seen in VMS as optional parameters or as item lists that go off the interface. We are VAX compatible in some ways. Our data types are the same. I mean, we're using integer as an integer, still 32 bits. We're hoping Fortran source that doesn't use a lot of VMS, you're just going to pick up, you're going to take over the other system, you're going to compile, and it's going to run. If it doesn't use any VMS services, there should be no problem at all. If it does, like I said, we're trying to support what we think are the core set that most applications tend to use. And again, we're implementing the runtime library, the math library, the lib library, and the string library. Mica's release strategy is very similar to what VMS is doing in version 5. Layered products and hardware aren't going to have to wait to a major release to get their thing out the door. Again, this is very similar to what VMS is doing in version 5. We think protected subsystems is going to be a way for layered products to add major extensions to the operating system and not require a new release of the operating system. Layered I/O support will allow us to add new function processors, which will dynamically come in and out of the system as we add new. Right now, we're only targeting towards one CPU, but we don't think that it's going to be a big problem to do multiple CPUs. We understand some of the problems, and we've learned some from VMS. Okay, Glacier is the compute server. This is Mica running on top of Moraine. Again, the server strategy that it hides behind VAX VMS, the interface that everybody's familiar with. It's a marketing decision if and when we ever do decide to become or when we do become a fully generalized operating system. The client compute server model that we are using is one of the big patents that we're working on. And we think that we've got a number of patents in this particular area. End user seamless. That's not the programmer, but that's the guy that runs the application. He isn't going to know if it runs on his workstation or if it's gone over to the Prism system and is executing on Mica. That's what we're shooting for. Okay. Client. For FRS, client is VAX VMS. In the future, that's going to be Alteryx. Or I think we're shooting long-term for like DOS, Unix, just generally. What exists on the client is several pieces. One, X server, which understands about how to deal with X windows. DFS, which understands how to the distributed file system support. And CCS, which is the client compute server. Client compute server is responsible for kicking off the process that runs on the server, which is Mica, and for supplying context needed by the application running on Mica, necessary for the application to run. Examples are translate this logical name. What is the value that you currently have that the server would ask the client to give me the value for? JCS is the guy that kicks it, a new process off. That's the job server. The application itself runs in its own bound process. That process is bound back to the client. The X library is the client side of the DEC Windows interface, and DFS again is the distributed file system. It's a shared file system using DFS between the two of them. Real easy. See the dollar sign? That's like VAX VMS dollar sign, you know, unless you change your prompt. The word prism is very likely to change, or it will change. But you just say Fortran, and my target system's a prism, and you'll say link, and you'll say run. You know it. I'm not sure about the Fortran compiler itself. The prism linker will actually run on Mica, so the link will actually occur on the other system. The run will actually occur on the other system. The compiler that we're using for implementation will actually run on the other system. I believe the Fortran compiler is in the same thing, where it will actually run on the Prism system. Again, when you say run the program, what happens is via RPC, we send over the appropriate thing to the other side. The image executes and happens over there. When it's finished, during its running, it can go back to the client, say, I need this for you to do me, supply me with this kind of context. When it's finished, it returns to the client. The client during that time is held up. I mean, he isn't doing anything else. The roles are reversed, and he's acting as the server for the server, which is the client at that point, to get context. Okay. Cheyenne is the other server product we're working on. This is the database server. Cheyenne is made up of the Stone hardware that Rob talked about, Mica operating system, and the Quartz relational database software. Now, the Quartz software is being done in Colorado. The Cheyenne product is self-contained. You buy an entire system, and it's, you know, the box hardware rolled in, software running, and it just sort of plugs in and starts working. It is compliant with the current digital architectures for the database and the distributed transaction architecture. It's not a general purpose machine, and neither is Glacier. There is no user interface code per se running on the system. We have a wide range of transactions per second, from an entry level to a very high, and we think this covers a large range of the market. The 7 times 24 operations is 7 days a week, 24 hours a day, 365 days a year. The availability and reliability numbers are pretty outrageous. And what we're doing and how we're having to design initially from the system to put in so that we meet these numbers is a lot of work being done in that area. We think we can expand a whole lot in this area. It's a real big market that digital really hasn't gotten into at all. Tandem and IBM are making lots of money out there, and they're going to be making a whole lot more, and we want our chunk. Overall, we see servers being done in this type of area as database servers, and really this is a new market for digital. Again, like Rob said, 100% data integrity is like required. The availability, you know, between 99.5 and that's 22 minutes a month. That's everything that the system isn't there. I mean, that's, if the system comes down, it's got to come back up. And the guy, field service, has got to go in there and replace a board, and it's all got to happen in that period of time. The performance, we're talking about end-to-end qualified debit credit transactions per second. And how we're getting some of these availability numbers is by doing a multi-box solution where there is more than one machine, where you can take one of the machines offline to do the repair and bring it back up. The operations that were happening on it fail over to the other one. The overall performance degrades during that period of time, but the database is still available. Now, this is the piece of the Cheyenne software that is being done in Colorado. A number of things they're doing with it, which I'm not a whole lot familiar, to be quite honest. It's a relational database system. It extends what digital currently has. It uses the same interfaces and architectures that we currently have. Again, right from the start, we have to look at high availability. I mean, this is a requirement in this market. We can't get around it. So you want a high availability system, you get a multi-stone Cheyenne system. Transactions can always be started within 2 minutes, 24 hours a day, 7 days a week, 52 weeks a year. Failure one component's not automatically compensated for. The front end restarts it. And they're restarted by the front end. The system can go in some kind of degraded performance if you only have a single box system. Pieces of it can fail away using the configuration manager. As long as they're not fatal to the operating system, the system will continue running. Okay. High availability, how we're getting it. This is a total system thing. I mean, this is working from the hardware all the way up to the software and everything in between and looking at the big picture. The isolated components just randomly thrown together isn't going to work. We've got a lot of ECC and parity on the hardware. Replication, as Rob was talking about, you're going to have 2 pairs of processors that can work together and shadow each other and say when one is in fault. We're working on this hierarchical fault management architecture within the operating system and down from the hardware all the way up into the operating system. The configuration manager is the high level of this. It understands about the faults that are happening and can forecast, you know, in the future we think this is going to go sour on you, why don't you back it up to another disk? Or if you have a shadowed set, it's like, we'll take this one offline, start using the other one, we'll start building things back up. We're also working on the transactions that are required to do the save commits and that kind of stuff. Cheyenne systems aren't small. I stress this is a mid-sized system, and this isn't anywhere near the number of RA60s and HSCs that are required. I mean, this is tiny. At the very top, there's your VAX system, your VAX VMS, in which the user interface runs. It makes calls over an NI, local area network, to the Cheyenne system, and then goes out over the CI. The CI system in the back here is local only to this Cheyenne system. It's the only way we can get the performance that we need from it and the connectivity that's required. Okay. This is the last part of the talk, and I'm going to talk a little bit about what the compiler group is doing. Currently, the compiler group is working in 4 different areas. The biggest 2 are Pillar and C. Pillar I'll talk about in the next slide. C will be ANSI compliant, highly optimized, good stuff. The assembler will be internal use only. internal into digital. And they're also working on a message compiler. We're working on internationalization, and Mica operating system we're shooting for it to be very easy, just to pull out all I/O that is seen on the screen or any kind of output is done through messages. All. There is no embedded text in any of the code. Thus, we will be able to remove these message files, put them aside, and plug in new ones for the language that we want to support. So the message compiler is extremely important to us. We think we're going to be it's one of the things that we're doing for internationalization. Pillar is the system implementation language we're using to code Mica. It's highly structured, it's strongly data typed, and highly optimized. I can't stress the strongly data typed enough. That's what's probably going to buy us our portability. You can't treat the same 32 bits without going through a fair amount of work as both an integer, as a pointer, as whatever. You've got to do some pretty hairy things which are called out pretty, you can't hide it. You're going to know when you've done it. What's interesting is that Pillar runs on both VAXs and Prisms, and that there will be a different Prism backend for each one of the Prism implementations. Now, implementations, I'm talking about CPUs. I'm not talking the same chip is being used for each of the workstations and for the Marine system. I don't believe that they're doing a different backend since it is the same chip. Currently, we have something called SIL, which is the ePascal compiler that has gone through several evolutions and is very similar to Pillar, and that's what we're currently coding in. We're hoping to see Pillar sometime later this summer. Now, how do 8 people do all that work in such little time? They got a good compiler shell. Very plug compatible, different front ends, different back ends, standard set of routines to allocate memory and do all kinds of things. The compiler shell runs currently under VMS. It will be very portable to Prism. It will be very portable to 64 bits. You have different targeted backends that you can plug in, both for VAX or for Prism. Those are in particular for the compiler. Each Prism implementation is a different backend, and that's what you switch when you go from 32 to 64 bits. Currently, the compiler shell is being used for all those things. The linker, librarian, beyond the language. The debugger that's being done in Palo Alto for the Ultrix is also using it. Important thing here, this is the summary. We got a common layered project target. Layered products aren't going to have to build a separate thing for Ultrix and a separate thing for Mica. They'll build one thing. If they build it right, recompile it, it'll work on the other system. Server strategy, Prisms are the back end to VAXs until there's a marketing decision to do otherwise and to become Mica to become a general purpose operating system. We believe we're going to shift to 64 bits without a whole lot of problem. We don't think that's going to be a big, big problem. We are now, the macro code that we are writing, which is very, very small, plus some of the data types that we had to do some funny things with. We think we understand what they are. We've gone from 64 to 32 to 64 to 32. So we've kind of gone through this a couple of times and kind of know the things to look out for and have been aware of it. Glacier is the compute server. It's end user seamless. The guy that's runs the application ain't going to know that it's over there running on his Mica. He just thinks his VAX got a whole lot quicker. The Cheyenne is the database server. It's an accelerator. The programs that run on the VAX and make the standard database calls will all of a sudden run quicker. It's one piece of a larger project yet being defined, which has a OLTP on the front end and some other things. That's what I had. So some questions? Sure.
Several. I'll try to take them one at a time. I'm just curious, what happened in history to idea of having a small kernel and running multiple OSs on top of it.
Wasn't working. We're getting pulled in two different directions, and they weren't compatible.
I guess you're saying experience showed it didn't work, that when you actually got down to defining services, there were incompatibilities.
We could do it, but you wouldn't like the cost. I mean, technically, it wasn't impossible. The feasibility of it is what we finally decided. Also, with the Ultrix product, there's a time to market constraint here that a year from now, we're out the door. So we didn't have time to build Mica all the way up. Sure.
You talk about the evolution of Ultrix once it's on Prism. That begs the question of whether it's going to be co-evolution, or are we going to end up with three functionally different Unix systems? And you're talking about changes for Prism, things that will happen to Ultrix. Do you expect that those changes will be reflected back into VAX Ultrix?
Yeah. Several things there. The changes that we need to port Ultrix from VAX to Prism will get reflected back into the VAX Ultrix, into those components that we are going to steal from their master pack in the long term to make it easier for us. There will be a number of changes which are specific very to Prism. Those we'll keep on to. That system, the kernel of that system, will eventually evolve closer and closer to Mica, and there'll be pieces of Mica that will be, go into that. Answer your question?
Well, no, maybe I'm asking a question that can't be answered right now.
Okay.
Can
Sure.
I go on?
Okay.
Sure, I don't.
You implied that you could take a relation view server and roll it out to a Unix system. What kind of function is this in any Unix system?
Not FRS, but that's one of the things we're definitely looking at. The initial client we're looking at is VMS. Beyond that, we're looking at Ultrix and Unix, yes, and we think I don't know, we're still looking at it. I'm not going to commit to it here, but that is one of the systems we're looking at. The other is MS-DOS and Macintoshes and everything else. That is currently what we're thinking about. We don't know how much of it's going to go. Yeah. No, DFS is a separate product that runs on top of VMS. I'm not even sure where it's done. And we're going to do our own implementation of that. It's almost a layer on top of what currently exists inside of the cluster. Sure.
You mentioned discretionary security in the form of ACLs. Do you give any thought to mandatory security?
I really don't know, to be quite honest. If you give me your name, I can get the correct person to... Oh, okay. We're saying discretionary, right?
You have discretionary,
and you were asking about mandatory ACLs and whether we were going to support them. Yeah.
questions. First, on RPCs. I don't know if I heard you quite right, but I heard you draw a difference between the corporate RPC standard and VAX RPC standard.
I don't understand the full relationship between the two of them. I understand there's a process going on for us defining what a corporate RPC standard is. It's not defined, to my knowledge, at this point. However, there is a VAX RPC that is currently defined, and that's what VMS and I are currently trying to get. We need something now, not a year from now or 2 years from now. Unfortunately, it won't make it for time. What we are planning to do is do the VAX RPC that is defined now, and over time we will go to the corporate RPC.
Second question is we have a fair number of customers who have a large amount of data in D format.
In what format?
D.
D format. Oh, okay.
Okay. It can be changed. It's on thousands and thousands of fields in mag tape.
I understand.
I understand there's no chance of getting either support or even perhaps an emulator on the machine to handle that. What can I tell my customers, and what will we have to do?
Don't have a good answer for that. I do know the correct people for you to talk to. If you come up to me afterwards, I can get you in contact with them. Hi.
16-bit language support.
16-bit language support, yeah. Oh, for Pillar?
Yeah.
Not planned as far as I know. Yeah.
Is AIO a proprietary interface?
AIA?
AIA.
Yeah, that's to digital. IBM recently announced a similar interface for their systems, which are really incompatible. AIA is sort of a level, same type of thing that we're doing.
So a customer might follow the AIA model or POSIX model and look at different sets of compatible
Yeah.
environments you can move to.
Yeah.
Workstation communications and data sharing model, is that?
With Ultrix?
Yes.
Okay. Eventually, the data sharing, I believe, is being solved with DFS. Okay. I'm not sure exactly all the communications that they're planning to support. They are supporting, I believe, ICPT. Yeah.
NFS, TCP, IP, and DECnet.
Yeah.
What about sharing between faxes and Ultrix workstations?
If they do it through those interfaces, I mean, maybe I'm missing.
Maybe I'm wrong. I was under the impression that DFS was only a file and not
Oh,
a record level.
that is correct. And you wanted to share on the file level? Currently, I don't believe there's any planned support for that. Yeah.
We drew a picture of a configuration for Cheyenne,
Mm-hmm.
which had the communication between the VAXs and the Cheyenne things over Ethernet.
That's correct.
Is that the only thing planned in particular for the Glacier for the compute server? Is that true as well?
FRS, that's it. We understand we're going to get much higher performance out of it that way. That it's going to be quicker over NI than it is over CI. I believe that's due to restrictions in DECnet that VMS is looking at. Yeah.
Why are we doing an unprepared operating system like Mica? Is that one extended more than
Good question.
The question was?
Okay, the question was, why are we doing Mica? Why aren't we just doing a better Ultrix? Because we believe there's features that we can put in Mica that we can't put in Ultrix. There are certain commercial things that we're addressing that we don't believe that we could address in Ultrix.
Do you get a lot of flack for marketing about this?
Excuse me?
Do you get a lot of flack for marketing about this?
Yeah, they know what we're doing. I'm not, I really don't know what their response is or what they're thinking about it. Is that it? Okay, sure.
Will Pillar be available to customers?
Yes, I believe so. That's a product.
Is Prism Ultrix really Unix, and would it help to call it that?
Internally or?
Either. Externally.
We can't call it Unix because it's a trademark of AT&T, so we have to call it Ultrix. So it's as much, it's Unix as much as Pax Ultrix is Unix.
Yeah.
If Mica becomes a general purpose operating system, has there thought been given to what the user interface is going to look like?
Not a whole lot at this point. There really hasn't. We're really focused on, what we've got less manpower than we need now, so we're not expending it on things that are too far out. Okay, thank you. Is the performance monitor going to give the same kind of information that the VMS performance monitor currently gives? I believe so. I can give you the person to talk to if you really want to know.